Hello everybody. Welcome to our continuation on the design process. Right now we are going to be going from where we left off, where we had our concepts that we generated, and now we have to go through the process of selecting the best option from all of our concepts. So we take our generated concepts and we bring them into our concept selection process. Doing this, we are going to be using a tool called decision matrices. These are also known as evaluation matrices. There are probably a dozen other different names for it depending on who you talk to in the world of design engineering. What is going to happen now is we take our concept, and the concept that we came up with, it should already be split down into a bunch of different subsystems. And we're going to have some number of subsystems that our design is broken into. For the design and manufacturing robots, it's going to be a mobile platform followed by some sort of bucket manipulator or a ball manipulator, whatever it might be. For each one of these subsystems, we'll get assigned one of those. Under each subsystem, we are going to have certain objectives that this design is being assessed based off of. These are objectives that are relevant to all the subsystems. So the same objectives are going to apply for all concepts within subsystem one. So every concept that has a subsystem one is going to be assessed by these same objectives. So we need to make sure that these are always important factors in our design, or to our design selection process. These might be things like cost, time to assemble, speed, precision. The list goes on and on and on. Controllability, maneuverability, reliability, et cetera, et cetera, et cetera. There are a ton of different objectives that we get to assign to all of these. Once we have all of our objectives, we are going to assign each one a weighing factor. So we are going to go and say, for each design, it is going to get some percentage importance. For every single one of our different factors or different objectives of our design. And all we need to make sure of is that all weighing, so these are called weighing factors. Let's write that out. And all we need to do is make sure that all of our weighing factors sum up to 1 for each subsystem that we are assessing here. And then we do this for every single concept. So this is for concept 1, for example, and then we repeat. For every concept, we're going to repeat the process of breaking it down into subsystems and going, and we are going to assess concept 1, subsystem 1 against concept 2, subsystem 1, and against concept 3's subsystem 1, etc. So now let's go ahead and move on over and see how this actually works with a real example. So what we are going to be looking at for our example is a crane hook. So if you think about this as the total design of a crane, The crane boom arm is going to be one object that would be a subsystem of the crane. The cabin would be a subsystem. And the hook that is actually going to hold everything is, you guessed it, a subsystem. So we are going to just look at a couple of different ways that we can go through assessing what design options we have for our crane hook and see which style of crane hook is going to be the best option for us moving forward. So you can already see what we have here. We have our objectives that we discussed before. These are the things that matter to our crane hook's design or to our assessment of the design. And each one of these has a weighing factor associated with it. If we go through and we sum up all of our weighing factors down here, we will get that it comes out to a score of 1.0. So we have everything all squared away to make sure that this is 100% of the things I care about are taken care of. We have here our parameter. The parameter lists what our quantification or what our assessment units are in. So we can see for cost, we've got dollars. For manufacturing costs, we've got dollars. For time, we've got hours. So all of these first three are what we call quantitative. So all we mean by quantitative objective is that we can quantify the value that goes in that area. Our next three are durability, repairability, reliability. These are all qualitative scores. So these are all qualitative objectives. And what we can see here is we have a separate table for score assignments for my qualitative objectives. And we'll get back to talking to this in a second. Our goal when we are going through decision matrices should always be to try and have everything quantified. We really want to have quantitative objectives wherever possible. So things like durability, we might actually be able to switch over from being an experience-based metric to a quantitative one. We could change this to cycles to failure. For instance, to make it quantifiable in the future. For right now, we are going to carry forth this example, but just remember, we should always be trying to use quantitative objectives. Those are the most important thing. Now, carrying on, continuing to look at our decision matrix, you can see that each design has each concept. This is going to be, we'll call it concept 2. This one would be concept 1. And then our cast hook would be concept 3. So you can see this is our crane hook subsystem from whatever concept 1, concept 2, etc. were. Each decision matrix has one major column for each concept to go into. Within each one of these concepts, or within each one of these subsystem columns for a concept, we have 3 subcolumns within it. The first column is our magnitude. This is the magnitude of our objective. That is it. So for this case of material cost, my cast hook costs $2,200, and it's pretty easy to go forth from there. So this right here is $2,200, and if we look at this, we will notice that $2,200 here is the cheapest score, or is the cheapest option. The other two are $2,500 each. So when we see that we have our best option here, $2,200 is lower than my other two scores, which are both at $2,500, it now received a score of 10. So it is my best option. It is my lowest cost option, so it gets my highest score possible, which is a score of 10. So now we go down to my next design that's more expensive, and we go, okay, how do I come up with my score of 8.8 for my other option that has 2,500 for its magnitude? So there are a couple of different options for ways to do it. The simplest one is to do linear score assignment. So what we are going to do is we are going to take our $2,200 example and say this is my best score. If we go and say divided by 2,500 times 10 for my number of points, so I have now created a linear ratio, 2,200 over 2,500 times 10, and this gives me a score of 8.8. So I am now able to go and say, okay, cool, I can plug in my score of 8.8 right here for my $2,500 riveted plate concept, and coincidentally, my welded plates have the same amount of material cost, so it also gets a score of 8.8 for that assessment. And if we repeat this for our other options, for our manufacturing costs, we can see that if I were to take my best score, being 1,200, well, 2,400 is double 1,200, and it winds up being half the points. So our linear scale assessment is still holding true over here in this with each one of our designs. For assessing our scores for my qualitative options, down here, I have my score assessment table. So we can see that my good option for my cast hook got a score of 8. That is the same 8 that I have over here in my assignment table. We will notice that everywhere else that there is a good, it also receives a score of 8. I cannot deviate from this table. I must include, or I must keep true to this. So even if I think that one of these options is a little bit better than good, but not quite great, I have to assign it a score of 8, or I have to expand my score assignment table to include more options for giving scores. That is one of the problems with qualitative assessments. Now that I have a score and I have a score for each one of my concepts, what I need to calculate out my value for that objective as it contributes to my total weighing factor. So to calculate my value, we can't really see that all that clearly. So my value is equal to score times my weighing factor. So we can see, okay, cool, my score is 10. My weighing factor is 0.1. So 0.1 times 10 equals 1.0. Cha-ching, I've got my 1.0. And then we sum up all of our values to get a total value, a total score for my design. And so what we have here, we have our 3 different scores in our decision matrix. We have a 6.1, an 8.2, and a 9.6. And we have highlighted, oh, that just crossed it out. We have highlighted the cell with my highest value, so I know that I am going with a riveted plate design for my crane hook on my total crane system. And that wraps up our brief description of, or brief analysis of going through a decision matrix and building decision matrices. Next up, we will actually be showing an example of a mobile platform decision matrix and all of the stuff that goes into assigning scores and distributing points for an example that is class relevant.